So solving for a derivative of a given function, especially if it is a complex function, could be quite tedious. Now, fortunately, there are different formulas that we can use in order for us to determine the derivative of a given function easily. And in here, or in this video, we're going to derive the derivative or the general formula that we can use in solving for the derivatives of an algebraic function, right? So let's start with the derivative of a constant, right? So the derivative of a constant or the derivative of any given function can be solved using the 5 steps differentiation. So now we're just going to derive a formula, the general formula that we can use in order for us to obtain the derivative of any given function easily. So for the derivative of a constant, alright, so for a derivative of a constant, say for example, we are given y equals k, or any constant. Now, the first step here is to change y to y plus delta y and x to x plus delta x. And since we have no x in the given function, so we're just going to replace y with y plus delta y. And then after this, we're going to transpose y on the right side. So this is the first step. Now, the second step is to solve for delta y, which is now k minus y, but y is equal to k, so delta y is equal now to k minus k. Or this is now equal to 0, right? So, if for delta 3, express explicitly, or we're going to express this side explicitly as a factor of delta x, but since we have no delta x in here, so this is now step number 3. And for step number 4, we're going to divide both sides by delta x, and 0 over delta x is equal to 0. And for number 5, obtaining the limit of delta y over delta x as delta x approaches 0, so this is now equal to 0. Therefore, alright, so therefore, the general formula for the derivative of a constant, dy over dx, or I should say, the derivative with respect to x of a constant is equal to 0. So this is our first formula. The derivative of any constant is actually equal to 0. So say for example, you are given the derivative of 4, right? So y is equal to 4. Now the derivative of y equals 4. The derivative of 4 dy over dx is equal to 0. Right? So if y is equal to 100, the derivative of y with respect to x is equal to 0. So the derivative of any constant is actually equal to 0. Next one, we're going to derive a general formula if we are given a function which is a function of power. So say for example, we are given y equals x raised to n, where n is any uh, positive whole number. So, or we can also use this formula for fractional exponent. So if we're going to determine the derivative of y equals x raised to n, the first step is to change y to y plus delta y and x to x plus delta x. So that is now x plus delta x raised to n. Alright, so in here, we have a binomial raised to a certain exponent, and the expansion of this one depends on the exponent here. But the general formula in binomial expansion is equal to, so what I'm saying is that if we're going to expand this one using the concept of binomial expansion, the expansion of this would now be generally x raised to n plus n multiplied by x raised to n minus 1 multiplied by delta x plus n multiplied by n minus 1 all over 2 factorial times x raised to n minus 2 delta x quantity squared plus, right? So we have n multiplied by n minus 1, n minus 2 all over 3 factorial multiplied by x raised to n minus 3 delta x raised to 3 until, right, so the second to the last term here would now be n multiplied by x delta x n minus 1, and the last term would now be equal to delta x raised to n. Alright? So this is actually the general expansion of x plus delta x raised to n. Now, if we're going to transpose y on the right side, so solving for delta y, this is now equal to x raised to n. So let me just rewrite this. Multiplied by n times x raised to n minus 1 delta x plus n multiplied by n minus 1 over 2 factorial x raised to n minus 2 delta x squared plus n multiplied by n minus 1 n minus 2 all over 3 factorial x n raised minus 3 delta x raised to 3 until n x delta x n minus 1 plus delta x raised to n. And the value, right? So the value of y here is x raised to n, so that is minus x raised to n. So basically, this x raised to n in here, right? And this x raised to n will cancel out. Thus, leaving us delta y equals, all right. So now, for the third step, we're going to express the remaining terms explicitly as a factor of delta x. So if we're going to factor out delta x in this expression, we have delta x multiplied by, all right, so n x raised to n minus 1, because we factored out delta x here. In this term, that is now plus n minus 1 over 2 factorial x raised to n minus 2. If we're going to bring out 1 delta x here, so the remainder would be 1 delta x. Now, for this term, if we're going to bring out delta x, we have plus n minus 1, n minus 2 all over 3 factorial. X n minus 3, if we're going to divide delta x here, right? So because we're going to bring out delta x, the remainder would be delta x squared. And for this term, we have plus n times x delta x, right? So if we're going to bring out delta x here, the remainder would be delta x n minus 2. And for this term, we have plus delta x. If we're going to bring out 1 delta x here, so that would now be n minus 1. So this is now uh, the resulting expression if we're going to factor out delta x in this expression. So, since we already factored out delta x here, what we're going to do is to divide both sides by delta x. So, this is now equal to n x raised to n minus 1 plus n multiplied by n minus 1 over 2 factorial x raised to n minus 2 delta x plus n minus 1 n minus 2 all over 3 factorial x raised to n minus 3 delta x squared plus n times x delta x n minus 2 plus delta x raised to n minus 1. Right? Because if we're going to divide delta x in here, this will basically cancel out. Right? So the resulting expression or the resulting equation would now be this one. And if we're going to determine the limit, alright, so for the last step, we're going to determine the limit of delta y over delta x as delta x approaches 0. So this is now dy over dx, that is now equal to, right, so if we're going to obtain the limit of this expression as delta x approaches 0, the first term would be equal to n times x raised to n minus 1. Alright, so we forgot here until there. So this is until there. Right, because I forgot to write this ellipsis here since we still have terms in between. Alright, so terms in between. Alright, so if we're going to determine now the limit of delta x approach as the limit of this expression as delta x approaches 0, then that is now n x raised to n minus 1 plus since we have delta x here that is equal to 0, we also have delta x here that's also equal to 0, and the terms in between this term and this term has also delta x in each term, so that will also be equal to 0. So plus 0, right? So we have delta x here, and then we also have delta x in here. Therefore, the derivative of y with respect to x is now equal to n multiplied by x raised to n minus 1. This is now, right? So this is now the general, this is now the derivative of y. What I mean is this is now the derivative of x raised to n. Alright, so now we are done with the derivative of, or the general derivative of a constant, the general derivative of a power. Now, for the general derivative of a sum, we're just going to determine the derivative of each term independently. Right? So this is actually, say for example, if we are given y, and this is a function of x, right? So say for example, this is a sum of a function of x and another function of x here. Therefore, dy over dx is now equal to f prime of x plus g prime of x. Right now, note that this f prime of x is actually the notion of the derivative of f of x, and g prime of x is also the notion of the derivative of g of x. So say for example, our y here is equal to u plus v, wherein u is a function of x and v is a function of x also. Therefore, dy over dx is equal to du over dx plus dv over dx. Right? So, in summary or generally, the derivative of a sum or difference of terms is actually the derivative of each term independently. We're just going to determine the derivative of each term independently. Now, for the derivative of a product, say for example that we are given y equals u times b, where u and v are functions of x, right? The derivative of this dy over dx is now equal to the the product of u multiplied by the derivative of v with respect to x plus v multiplied by the derivative of u with respect to x. So, the derivative of y equals u times v is equal to u multiplied by the derivative of v with respect to x plus v multiplied by the derivative of u with respect to x. Right? So, that is another formula to note. Alright. Now, for the derivative of a quotient, say for example, we are given y is equal to u over v, where u and v again are functions of x, right? So these are functions of x. Now, the formula that we are going to use here would be dy over dx, that is now equal to v multiplied by the derivative of u with respect to x minus u multiplied by the derivative of v with respect to x all over v squared. Alright? So, this is the general formula for the derivative of a quotient. To summarize, these are now the different formulas that we can use in determining the derivatives of a given algebraic functions. Right? So, first, the derivative of a constant is always equal to 0. Alright? So, this is formula number 1. For the second one, the derivative of a power. Alright, so the derivative of x raised to n, that is equal to n multiplied by x raised to n minus 1. Alright, so formula number 2. The derivative of, right, so the derivative of sum or difference of terms, so say for example we have derivative of u plus v, this is now equal to the derivative of u with respect to x plus the derivative of v with respect to x. Right? So formula number 3. We're just going to obtain the derivative of each term independently. Right? And then the derivative of a product which is u times v, where u and v are functions of x. We have u multiplied by dv over dx plus u plus v multiplied by du over dx. So this is now the fourth formula. And for the last one, the derivative with respect to x of u over v, where u and v are functions of x. So this is now equal to v du over dx minus u dv over dx all over v squared. Alright, so these are the first 5 formulas that we can use in determining the derivatives of algebraic functions. Alright, so going back to our first example in the 5 steps differentiation, the derivative of y equals x squared plus 3x minus 1 was solved to be 2x plus 3. Now, using the 5 steps differentiation. Now, if we're going to use the formula that we derived, solving for the derivative of y equals x squared plus 3x minus 1, using the formulas, we now have dy over dx equals, since we have sum of terms or sum and difference of terms here, we can solve the derivative of each term independently. So the derivative of x squared, so this is x raised to n. And the derivative of x raised to n, alright, so the derivative of x raised to n is n multiplied by x raised to n minus 1. So since our n here is 2, therefore this would now be equal to 2 multiplied by x raised to n minus 1, and 2 minus 1 is equal to 1. So that is 2 times x raised to 1. And the derivative of 3x here, right? So since this is now equal to 3 is the coefficient here, so we can just bring it out first, right? So if we can bring it out and solving for the derivative of x, this is now equal to 1 multiplied by x raised to n minus 1, and since 1 here, our n here is 1, so that would now be 1 minus 1. And the derivative of negative 1, since it is a constant, so that is equal to 0. And simplifying this, we now have dy over dx equals 2x plus 3. X raised to 0 is equal to 1, so basically that's equal to 1. So that would now be 2x plus 3 times 1, or simply 2x plus 3. Alright, so let us now discuss the power rule in differential calculus. Now, if we are given y equals x raised to n, the derivative of this one with respect to x is now equal to n, x raised to n minus 1. Alright, so this was the formula that we derived. However, for the general power formula, right, so for the general power formula, if the base here is a function of x, not simply x, therefore, if, say for example, we are given y equals u raised to n, where u is a function of x, the derivative of y with respect to x would now be equal to n multiplied by u raised to n minus 1 multiplied by the derivative of u with respect to x. This is now the general power formula. So as an example, for our second example in the 5 steps differentiation, we have y equals x plus 3 raised to 2. So if we're going to apply this formula, n u raised to n minus 1 du over dx, where u is x plus 3 and n is equal to 2, dy over dx is now equal to 2 multiplied by x plus 3 raised to 2 minus 1 multiplied by the derivative of u, and the derivative of u is x plus, what I mean is the derivative of u here, or the derivative of x plus 3 with respect to x is now equal to, so let me just rewrite it, 2x plus 3 multiplied by the derivative of x. So the derivative of x is equal to 1. The derivative of constant is equal to 0. So if we're going to simplify this, we now have 2 multiplied by x plus 3 multiplied by 1, or dy over dx is now equal to 2x plus 6. Now, going back to our example number 2 in the 5 steps differentiation, we have y equals x plus 3 raised to 2, and we use the 5 steps differentiation here. The answer that we obtained here is the same as the answer that we obtained using the formula or the general power formula. For example number 3 of the 5 steps differentiation, we have y equals 2 over x plus 3. Now, this is a quotient. So, the derivative of a quotient, the derivative with respect to x of u over v, where u and v are functions of x, this is equal to v multiplied by the derivative of u with respect to x minus u multiplied by the derivative of v with respect to x all over v squared. So if we're going to apply this formula, and 2 is u, alright, and x plus 3 is our v here, this is now equal to v, which is x plus 3, multiplied by the derivative, right? So the derivative with respect to x of u, and u is equal to 2, minus 2 multiplied by the derivative with respect to x of x plus 3, all over v squared, so that is x plus 3 quantity squared. So this is now equal to, the derivative of a constant is equal to 0. So basically x plus 3 times 0 is equal to 0, minus 2 multiplied by the derivative of x is equal to 1, right? The derivative of 3 is equal to 0 because that is a constant, all over x plus 3 quantity squared, or dy over dx is now equal to negative 2 over x plus 3 quantity squared. So again, if we're going to go back to our example number 3 here using the 5 steps differentiation, the derivative of y equals 2x plus 3 is now equal to, right? So that's now equal to negative 2 equals x squared plus 6x plus 9. Now, our answer in using the formula, we have dy over dx equals negative 2 over x plus 3 quantity squared. This was our answer using the formula. Now, if we're going to expand x plus 3 raised to 2, that is x squared plus 6x plus 9, which is actually the same as this one, right?